So in the previous slide, we just talked about model-based reinforcement learning approaches, and we talked about Markov decision process and the dynamic programming. Now, let's discuss about two more. One is Monte Carlo and one is temporal difference. Now, these two approaches, unlike the Markov decision process approaches, do not assume any model of the environment, because it means that they do not know the model of the environment. It doesn't know what is the transition. There is nothing called a transition probabilities, and it doesn't know what is the transition probabilities and stuff like that. So those are called non-model or approaches without a model of the environment. Now, there are two differences in terms of Monte Carlo and how temporal differences are. Monte Carlo assumes, or it learns from a complete episode which is done. And I'll give you an example of let's say we take an example of a food truck. You have a food truck, and these food trucks sells different kinds of objects. Let's say it sells only one thing, burgers. And burgers, it sells from say Monday to Friday. Let's assume that it doesn't sell on the weekends. Now, obviously, your aim, or you as an owner of the food truck, is to maximize your revenue. Now, say for example, at the beginning of the week, you start with some level of inventory, and then during the days, say Monday to Friday, you consume these inventories, and then you buy more, and then you keep it, and that's the way. And your rewards would be based on how much of revenue you make, that how much you sell. But there is also the cost angle. That is, you can't just keep a lot of buy a lot of stock and then keep it there. Probably it'll get bad. Or you might not have all those sales, so which could again result in loss for you. So your ultimate aim is to learn some policy or some formula which in reinforcement learning parlance we call it a policy. What is the most optimal? The policy should be to learn what is the most optimal kind of inventory to keep, so that you maximize your revenue at the end of the day. Now, in a Monte Carlo approach, the learning happens by looking at the complete episode. That is, it starts from Monday to Friday. It looks at the complete episode of sales from Monday to Friday. It's not just sales alone. The sales, the inventory you keep at each level each day, how the sales has happened, and what revenues do you get, what profits do you make based on your inventory which is not being sold, etc. So it looks at complete episode from Monday to Friday to do the learning. So that's called the complete looking at the complete episode. Now that's the approach of Monte Carlo. Now in temporal difference, you don't look at a complete episode. You look at the next episode and tries to adjust your learning based on the rewards which you get, or in this case, what is the profit which you get in the next day. Say for example, you are on Monday, you have certain amount of inventory, and you do a certain amount of sales, and you get a certain amount of profits, and then based on your inventory level and based on the policy which you decided, that okay, you buy more inventory, and then you get into Tuesday, and on Tuesday also you get certain kind of sales and some returns. So based on the returns which you get on Tuesday, your update for Monday is happening, or the policy for update for Monday happens. Now let's look at what is this policy. Policy could be, say, you could fix a policy saying that okay, as soon as this inventory gets lower than say 100 units, you buy more stock and then maintain it to 300 units. Let's say that's the policy. So that's the policy. So you are during this reinforcement learning process, say using a Monte Carlo or temporal difference, you're trying to assess how good that policy is, whether this will give you a reward in the long term basis. So the differences between Monte Carlo and temporal difference is this. So to check those policy which you have fixed, you look at complete episode right from Monday to Friday. You in order to get this get this learning and updates for Monte Carlo, but temporal difference just looks at the next step and then tries to adjust the policy. So this is the difference between Monte Carlo and temporal difference. We will get into Monte Carlo and temporal difference in a future post, wherein we will try to build something using Monte Carlo approaches and temporal differences. Now let's get into, having learned some of the basic kind of traditional reinforcement learning. Let's get into something called the reinforcement or deep reinforcement learning in the next slide. So in the past few slides, we talked about some of the traditional reinforcement learning problems like your multi-armed bandit, your Markov decision process, Monte Carlo, temporal difference, etc. Now, and you also know that you have different states, and from states you take actions, and what actions, and taking those actions you get into other states, and ultimately the objective of a reinforcement learning agent is to try to learn a policy which gives you the best rewards from a long-term perspective. We understood that from the food truck example we talked about. Now, what happens in real life, many of these real life problem settings, is the number of states and the different types of actions which you can take could be huge. Say, for example, in an online e-commerce setting, the different types of states in which you end up could be extremely large. And this is where deep reinforcement learning came into a picture, because in traditional reinforcement learning settings, when the number of states becomes very large, it becomes really intractable, or it becomes the systems becomes too complex. So that's when deep learning techniques were combined with the traditional reinforcement learning problem set to find the best policies using deep learning techniques, and we use artificial neural networks to find those policies. And at the end of the day, the objective is to find the best policy using best policy for a specific context, and use different types of deep learning techniques to find the apt policy. So this is all about deep reinforcement learning. This is just a small primer. We'll get into deep reinforcement learning in future posts. Now, having understood different types of reinforcement learning approaches, which from the traditional to deep learning reinforcement learning, we'll try to get into the context of how does these reinforcement learning techniques gets utilized as a recommendation system. Or just give a small context in terms of how these can be used as a recommendation system, because at the end of the day, your whole series is about how do you build a recommendation system using reinforcement learning, and specifically multi-armed bandit problem. So let's get into that next.